The James Webb Space Telescope released its first images in July of this year, and we are still in awe of how stunning they are. We've been accustomed to the Hubble Telescope capturing our photographs for the past 30 years, but with the JWST in full swing, Hubble's legacy may be short-lived. The level of detail and clarity is unrivaled. When you see the telescope's new perspectives on well-known objects, like the Carina Nebula and the planet Neptune, it's as if you're wearing new spectacles with a stronger prescription. In this video, we'll take a look at why the James Webb Telescope just caused a terrifying crisis. Close your eyes and imagine space, and chances are your mind will bring up a Hubble image. The images captured by the Space Telescope became well known in the 1990s, appearing on television as well as in magazines, newspapers, and movies. It created a shared visual lexicon of outer space over the decades, seeding the imaginations of multiple generations with visions of glowing nebulae, haunting planets, and faraway galaxies. Hubble is still going strong more than 30 years after it was launched. However, its successor promises to outperform it. Through various observations of objects in our solar system and the very distant universe, the Hubble Space Telescope has improved our understanding of the universe over more than 3 decades. Hubble's successor, the James Webb Space Telescope, named after NASA's second administrator, James E. Webb, began observations this year. Aside from stunning images of the Carina Nebula, Stephan's Quintet, and the Southern Ring Nebula, the first JWST observations yielded scientific results that baffled astronomers and astrophysicists. Galaxies in the early universe are far more massive than predicted by the standard cosmological model. The first images from the James Webb Space Telescope were released to the public on July 12, 2022, and they are breathtaking. The clarity and level of detail are exceptional. Seeing the telescope's new views of familiar objects, such as the Carina Nebula and the planet Neptune, is like putting on new glasses with a stronger prescription. Only the first batches of JWST images have been released thus far, but each image has caused a stir, implying that the telescope's images will infiltrate the public's subconscious just as thoroughly as Hubble's in the coming years. As one Jesuit astronomer working at the Vatican's observatory put it, "God's creation being revealed to us, and in it we can see both His astonishing power and His love of beauty." But far from praising God's creation, the JWST is now sending back data that calls into question that modern creation myth, the Big Bang Theory. As it looks deeper into space, it is challenging long-held beliefs about the origin and evolution of the universe, and it is shedding brilliant light on profound and important philosophical and scientific questions. The JWST was launched into orbit 1.5 million kilometers from Earth last December, and after 6 months of calibration and only 12 hours of full operation, it produced the most stunning images. It promises to transform our understanding of the universe and our place within it with its powerful 25-square-meter eye, capable of detecting a broad spectrum of infrared light with 100 times the power of its forerunner, the Hubble Telescope. Since 1995, approximately 5,000 exoplanets have been discovered. The James Webb Telescope will aid in their study and determination of whether some of them have the necessary conditions for life. The new images depict matter's spectacular variety at all of its incredible stages of evolution. They reveal a universe that is the site of massive processes of birth and destruction, of unimaginable tensions that generate galaxies and stars, and out of which the conditions for life emerge. Breathtaking panoramas that depict the evolving complexity of matter in its dialectical development. The victory is especially sweet given what it took to get JWST here. Scientists began planning it more than 3 decades ago, and the construction effort fell so far behind schedule and so far over budget that many feared it would never be launched. Astronomers felt a rush of relief when the telescope finally lifted off on December 25, 2021, at a cost of nearly $10 billion. JWST performed even better than expected over the next 6 months, and astronomers began to have a good time. Scientists are overjoyed right now. In the 3 months following the initial release of the telescope's results, scientists submitted approximately 200 papers, interpreting them to the preprint server ArXiv. The lucky researchers whose proposals were chosen in a highly competitive, peer-reviewed selection process have already reserved the telescope's initial observing time. Journalist Jonathan O'Callaghan explains how some of those images have already caused havoc in the field of cosmology. Fabio Pacucci, an astronomer, describes how Hubble and JWST have changed science by photographing empty space. Soon, the first image that comes to mind when we think of space may be one of JWST's. It is unclear how long it will last and what its ultimate legacy will be, but it's definitely off to a good start. If images from the legendary James Webb Space Telescope continue to astound you, you're not alone. The Space Observatory has provided us with detailed images of distant galaxies, nebulae, and even our cosmic backyard. However, Harvard and MIT scientists warn that the models used by astronomers to analyze James Webb's data may be flawed. Astronomers claim in a new study published in the journal Nature Astronomy that data from the telescope can impede scientists' ability to define a habitable planet. Why could James Webb's data be incorrect? Opacity models, which model how light interacts with matter as a function of the matter's properties, may require significant returning to match the precision of JWST data. According to a press release, important life-defining properties such as temperature, pressure, and elemental composition may be misinterpreted if such models are not refined. There is a scientifically significant difference between a compound like water being present at 5% versus 25%, which current models cannot differentiate, says Julian DeWitt, co-leader of the study and assistant professor in MIT's Department of Earth, Atmospheric, and Planetary Sciences. According to DeWitt, the current data processing model is known as Rosetta Stone language translation and was also used on the Hubble Space Telescope. More work, however, is required for greater accuracy. Now that we're taking Webb's precision to the next level, DeWitt explained, our translation process will prevent us from catching important subtleties, such as those that make the difference between a planet being habitable or not. According to the paper, JWST predictions would be unable to distinguish between a planet with a 300 Kelvin atmospheric temperature and another with twice the heat at 600 Kelvin. There would be so much more we could do if we knew exactly how light and matter interact, said Nerella, a graduate student who worked on the study. We know that around Earth's conditions well enough, but when we move to different types of atmospheres, things change, and that's a lot of data, with increasing quality, that we risk misinterpreting, Nerella added. Despite the fact that JWST was designed to withstand the occasional brush, its teams have now devised a strategy to minimize potential collisions with micrometeoroids. The telescope, which was launched on December 21, 2021, has been hit by 14 measurable micrometeoroids so far, averaging 1 to 2 hits per month. One of these impacts resulted in some optical errors, but JWST's teams were prepared for such occurrences. While JWST has survived micrometeoroid impacts thus far, scientists claim that one of the impacts was stronger than their pre-launch models had predicted, forcing them to reconsider how to keep JWST in space for as long as possible. Following the May impact, NASA assembled a working group of experts from the JWST team, the Space Telescope Science Institute, the NASA Meteoroid Environment Office, and mirror manufacturers. They investigated the impact and discovered that such an impact was statistically uncommon because it struck a particularly sensitive location on the mirror. Regardless, the team decided it was best to change the method of observation, forcing the telescope to face away from the micrometeoroid avoidance zone. Micrometeoroids that strike the mirror head-on have twice the relative velocity and 4 times the kinetic energy, said Lee Feinberg, JWST's optical telescope element manager, in a NASA statement. This shift in strategy will not limit the telescope's capabilities. Instead, it will only make certain observations when it is free of micrometeoroid impacts. This may not be the case for time-sensitive observations, which will proceed as usual. We don't pretend to be cosmologists. We make no claim to provide comprehensive solutions to such problems. However, we are confident that new discoveries and observations, such as those made by the JWST, will confirm the materialist viewpoint and debunk several concepts. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.